Hey everyone, this video is for this peer graded assignment course project as part of the Machine Learning Foundations for Product Managers by Duke University in Coursera. So the assignment is about how do we model the prediction of net hourly electrical energy output of a combined cycle power plant. And these are the input variables that are given to us. So basically, I took the data set, took 15% out as a test set, and the rest 8,000 above 8,000 records as my training set. And then 10% of that I separated as a validation set, so about 813 rows. So the first thing I did was I put them in some scatter plots, the relation between each of these variables to the output variables, as well as some of the relationship between, for example, temperature and humidity. So I built a couple of regression models, one using all of the features, and in the other one, I removed ambient pressure. Mostly because I just know Excel. If I had known Python or maybe something else, I'd probably used the ridged regression so that if there is any collinearity between these variables, we could have accounted for that. So what I first did was this first regression with all the features. As you can see, the R square is pretty high, so almost 93% of the outcome variable is explained by these features that are there. Then I did it only without the ambient pressure. It's just slightly less than what I did with all the features, so it's not really much big of a difference. Ideally, if, like I mentioned before, if we could have done a ridge regression, might have been able to see some difference, but it was a very lengthy process to figure it out in Excel. So after creating these regressions and then knowing my coefficients, I basically took it to this tab where I had my validation data set. So for both of these predictions, I calculated the mean squared error, absolute error, and percentage. And as I mentioned, they're pretty close, but as you can see, one has a slightly lower error rate percent than two. So for my test set as well, I took the one that has the slightly better error rates. And as you can see, the output in the final test set is also almost the same as the validation set. So I think the regression model does kind of overfit the data, but if there was any other mechanism like bridge regression or any other way to do this, which would have been easier in Excel, maybe we could have seen some additional differences. Let's see. In terms of the questions that were being asked, like I mentioned, we are predicting a numerical value, so I chose the regression model. My output metrics was the coefficient of determination, as well as I wanted to use the mean absolute error percent because it's easier to communicate in terms of percent than absolute numbers for errors. I built the scatter plots in order to identify what features I should ideally add into my relationship. As I mentioned, I removed the 15% to get to the test set. Then I took another 10% as my validation set. The first one was the multiple linear regression with all the features, and then the second one was still a multiple linear regression where I removed the ambient pressure as a variable. I think that's it. Thank you, guys.